In this video tutorial, we will learn some tests to distinguish between pair of organic compounds. The question from this topic carry 2 to 3 marks weightage in CBSE board examination paper. First is iodoform test. Only those compounds having either CH3CO group, that is methyl ketone group, or CH3CHOH groups give this test. Compounds like acetone, acetaldehyde and propanol when treated with NaOI, or we can also write I2 plus aqueous NaOH in place of NaOI, because when I2 reacts with NaOH it will yield NaOI and HI. So when this reaction proceeds, CHI3 is produced as a product. CHI3 is iodoform having a yellow precipitate. So due to the formation of this yellow precipitate, we can know which compounds gives the iodoform test. So let's consider some questions. Differentiate between following pair of compounds. First is methanol and ethanol. Methanol has a structure HCHO and ethanol is CH3CHO. In ethanol, CH3CO group is not present, as well as CH3CHOH group is not present. Therefore, this compound will not give the iodoform test. Ethanol. In ethanol, CH3CO group, which is methyl ketone group, is present. Therefore, this compound will give the iodoform test, and hence iodoform test can be used to distinguish between these pair of compounds. Second is propanol and propan2ol. Propanol is CH3 CH2 CHO. Again, there is neither CH3CO group nor CH3CHOH group in propanol, so this compound will not give the iodoform test. Whereas the structure of propan2ol is CH3CH propan carbon. This is propan2ol. Sorry, this CHOH CH3. In this compound, CH3CHOH group is present. Therefore, this compound will give the iodoform test. Therefore, iodoform test can be used to distinguish between these pair of compounds. Now, see the third question. Acetone. Acetone is CH3 CO acetone is CH3 CO CH3, and this is diethyl ether, means C2H5 O C2H5. So in acetone there is the methyl ketone group is present in acetone, whereas in diethyl ether there is neither CH3CO group nor CH3CHOH group. Therefore, this will give the iodoform test, whereas this compound will not give the iodoform test. Therefore, again this test can be used. Fourth question. Now see here, acetophenone. The structure of acetophenone is COCH3, and structure of benzophenone is benzene ring CO again benzene ring. So in acetophenone, the methyl ketone group is present, therefore this will give the iodoform test. Whereas in benzophenone, there is neither methyl ketone group nor CH3CHOH group, therefore this will not give the iodoform test. So this is our first test which can be used to distinguish between a pair of organic compound, and these are the questions. This is the complete iodoform test.
Thank you.
The second is the AgNO3 test or silver nitrate test. Firstly, we need to know that which are the compounds that give this test. Alkyl halide Rx, benzyl halide benzene ring CH2X, and allyl halide gives AgNO3 test. Allyl halide are the compounds in which halogen atom is bonded to the allylic carbon. Allylic carbon means the carbon next to the double bond. Whereas vinyl halide and aryl halide does not give AgNO3 test. Vinyl halide are the compounds in which halogen is bonded to the doubly bonded carbon atoms. So when alkyl halide, benzyl halide and allyl halide reacts with aqueous NaOH, then the reaction proceeds through nucleophilic substitution reaction, and Na and X forms the side product NaX, and these are the resultant compounds. When excess of AgNO3 is added in the presence of dilute HNO3, then PPT of AgX is precipitated in each case. If X is chlorine, then AgCl will be a white PPT. If X is bromine, then AgCl will be dull yellow PPT, and if X is iodine, then AgI is a dark yellow PPT. So depending on the color of the PPT, we can distinguish between the pair of organic compounds. Suppose the question is distinguish between chlorobenzene and benzyl chloride. This is the structure of chlorobenzene and this is benzyl chloride. Chlorobenzene is aryl halide and benzyl chloride is a benzyl halide. Now see here, aryl halide does not give AgNO3 test, so this compound will not give AgNO3 test, whereas benzyl halide gives AgNO3 test. Therefore, these pair of compound can be distinguished. The second question is distinguish between chloromethane and bromomethane. Now both are alkyl halides, so both will give the AgNO3 test. But now, depending on the color of the precipitate, we can distinguish between them. When CH3Cl is treated with NaOH slash then AgNO3, then a PPT, white PPT of AgCl will be precipitated, and if in case of bromomethane, a dull yellow PPT will be precipitated. So depending on their color, we can distinguish between them. This is the complete AgNO3 test. Third is Azodye test. If we want to differentiate between 1 degree aliphatic amine and 1 degree aromatic amine, then we can perform this test. Suppose 1 degree aliphatic amine with ethylamine, when it is reacted with HNO2 at 273 Kelvin or 0 degrees Celsius, then it is converted into corresponding alcohol CH3CH2OH with the liberation of N2 gas and a water molecule. If 1 degree aromatic amine is used when it is reacted with HNO2, or we can also take NaNO2 plus HCl in place of it at 273 Kelvin, then BDC, benzene diazonium chloride, is formed. The process of conversion of aniline into benzene diazonium chloride is known as diazotization. When BDC is formed, it is then reacted with 2 naphthols. See here, when 2 benzene rings are fused, the compound is known as naphthalene. If an OH group is substituted at beta carbon, alpha this is beta carbon, when an OH group is substituted, then the resultant compound is known as beta naphthol, or we can also say 2-naphthol. So when BDC is reacted with 2-naphthol, then I am showing here an H atom, so that the side product is minus HCl, and then the resultant compound can be written as, this is the benzene ring, N2 and double bond N, that is N2, then N2 gets attached to this carbon. So this is the resultant compound. This compound gives a characteristic color and therefore is known as azodye. This is a complete azodye test. Suppose there's a question, differentiate between aniline and ethylamine. Aniline is 1 degree aromatic amine and ethylamine is 1 degree aliphatic amine. This is ethylamine. So this will give the azodye test, whereas this will not give the azodye test. Therefore this test can be used to distinguish between these pair of compounds. In examination you should also write these two reactions. Marks will be allotted for that reaction. This is the complete reaction. Fourth is the ferric chloride test. Only aromatic alcohol give this test. So when aliphatic alcohol ROH is treated with FeCl3, no reaction occurs. But when aromatic alcohol reacts with ferric chloride, then ferric phenoxide is formed along with HCl. Now how this reaction is carried out? First, aromatic alcohol, phenol, breaks into phenoxide ion and H plus ion, and FeCl3 breaks into Fe3 plus ferric ion and chloride ion. Then these two ions interact with each other, and these two ions interact with each other. So the compound formed from these two ions is ferric phenoxide, and the other is HCl. So this test is used to distinguish mainly aliphatic alcohol and aromatic alcohol. Next test is Lucas test. Lucas reagent is concentrated HCl plus anhydrous ZnCl2. I am writing it Lr. If we want to distinguish between 1 degree alcohol, 2 degree alcohol and 3 degree alcohol, then we can use Lucas test. When 1 degree alcohol is treated with Lucas reagent, then the turbidity or cloudiness in the solution appears on strong heating. So the turbidity don't appears immediately. In 2nd degree alcohol, turbidity appears after 5 minutes, whereas in 3 degree alcohol, when it is treated with Lr, then turbidity appears immediately. So you can distinguish between these different alcohols depending on their turbidity. So this is the Lucas test. Sixth test is the sodium bicarbonate test. All the carboxylic acids, whether they are aliphatic or aromatic, all give NaSCO3 test. When aliphatic or aromatic acid is heated with NaSCO3, then they gets converted into their corresponding sodium salt with the evolution of effervescence of CO2 gas and water molecule. This effervescence indicates that these compounds give sodium bicarbonate test. The 7th test is sodium test. This test is given by all alcohols, 1 degree, 2 degree, 3 degree, benzyl alcohol and aromatic alcohol, as well as by carboxylic acids, whether they are aliphatic or aromatic. When they are treated with metal Na, since alcohol and carboxylic acids are acidic in nature, and when acid reacts with metal, then H2 gas is released. So therefore ROH plus Na gives RONA plus H2 gas, and RCOH gives RCONA, corresponding sodium salt plus H2 gas. So this test can also be used to distinguish a pair of organic compounds. Now if you want to distinguish between cyanide and isocyanide, so this is the following test. You can perform the following test. They can be differentiated on the basis of reduction process. Cyanide, the cyanide reduces to give 1 degree amine, whereas the isocyanide compound reduces to give 2 degree amine in the presence of alcoholic Na. The reaction can be shown as 4 hydrogen atom H here's H, so R CH2 NH2. When this bond gets broken, 1H, this side 3H, so R NH3. So this is the complete reaction, and on the basis of which you can differentiate between any cyanide or isocyanide compound. The ninth test is the Hinsberg's test. It is a separate topic in itself in your textbooks. So first we need to know that what is Hinsberg's reagent. SO2Cl2 is sulfonyl chloride. If one Cl atom is replaced by benzene ring, then the resultant compound is called benzene sulfonyl chloride, as it is derived from this. This is Hinsberg reagent. Its molecular formula is C6H5SO2Cl2. SO2Cl. When it is used to differentiate between 1 degree amine, 2 degree amine and 3 degree amine. When 1 degree amine RNH2 reacts with HR, Hinsberg reagent, then HCl is released as a side product, and the resultant compound is RNH, SO2 and benzene ring. Its IUPAC name is N-alkyl benzene sulfonamide. It is acidic in nature. When it is heated with excess of aqueous KOH, then the resultant potassium salt is soluble in KOH solution. Whereas when 2 degree amine is treated with HR, then with the evolution of HCl, the resultant compound is N-dialkyl benzene sulfonamide. When it is treated with excess of aqueous KOH, then the resultant potassium salt is insoluble in KOH solution. So see here, the resultant potassium salt in this case is soluble, whereas in this case is insoluble. The reason being that the H atom bonded in this compound, the H atom bonded to nitrogen in this compound is highly acidic. So it forms soluble salt with KOH solution, whereas there is absence of this acidic H atom in N-dialkyl benzene sulfonamide. Therefore, its potassium salt will not be soluble in aqueous KOH, whereas 3 degree amine does not react with Hinsberg's reagent. So this test can be used to distinguish between all these 3 types of amines. So here is an important question. Differentiate between methyl ethanoate and ethyl ethanoate. This is methyl methanoate and this is ethyl ethanoate. Now in the previous section I haven't elaborated any topic in which we can distinguish esters. So what to do now? Acid hydrolysis of each is carried out. When acid hydrolysis of methyl methanoate is carried out, then here OH and there H. CH3COH will be formed along with CH3OH. When acid hydrolysis of ethyl ethanoate is carried out, then again this bond will be broken, CH3COH and CH3CH2OH. Now in both the cases acetic acid is common in both, but you can differentiate in between these 2 compounds depending on the alcohol. Here the alcohol is methanol and here the alcohol is ethyl alcohol. Now how to distinguish between them? In this compound, in this methanol, there is no CH3CO group, methyl ketone group, yes, there is neither CH3CO group nor CH3CHOH group, whereas in C2H5OH there is CH3CHOH group. So therefore this will give negative, this will not give iodoform test, whereas this will give positive iodoform test. So therefore these two can be differentiated. So we are left with some more tests. First is carbon element test, second failing test, third is tolerance test, and the fourth is bromine water test. I think there's no need to elaborate this topic as we had already discussed it in previous classes, and the rest will be discussed in the later section. Thank you.